I really love the versatility of estimating. I've been working on that some this week with a client, and just want to do a video show you how to use formulas in the system and then embed them into a labor code so that it makes decisions for you on some things. So what I'm going to do to illustrate it, I'm going to have two different burn functions, then have the system determine which one to use in a formula. So it's pretty cool. Just love the versatility of it. So just to show you, I have two different burn factors here, which I renamed. I've got one called plate machine, but this is plate with plasma. And then I got this one, plate machine oxy. Actually, probably ought to do this for clarity and say plasma. So that one's my plasma, that one's oxy. And so I'm going to say I can use plasma. I don't know, I'll put it up to like 1.5 inches or something. And then after that, use oxy. So what I'm going to do, I'm going to go over here and I'm going to build a labor code. So let me go into labor codes. Or actually, I'll just put it into, let me filter down for plate. Instead of using this CAN formula, which basically says if I can shear it, then shear it. Otherwise, this one has burn manual. I'm going to just say I don't have a shear. I have two plate machines, and I'm going to decide which one to use. So I'm going to replace this formula with one I want to create. But if I check this, there's not going to be a formula like that in here. So I'm going to build this out and say formula maintenance up here. And let me just go down to a burn function, and I'll just kind of use it to copy. I'll just say new burn. So I'm going to say quantity of 1, but here in edit operation formula, instead of saying just one burn option, I'm going to say if the thickness is less than or equal to 1.5 inches, then I want it to use burn plasma. Otherwise, I want it to use burn oxy and add that. So I've got an if-then statement, so it'll make the decision for me about which one to use. I'm going to say okay, and then I'm going to say the thickness is not a flange thickness, is going to be the thickness of the plate. So here I'm just going to put in thickness and add that variable. And then the length of this is going to be, we're going to say width times 2. Let me put that in parentheses. Plus another parentheses length. While I go to it, I can just type it. I'll go length times 2. So that'll give me my total inches of burn. So now I'm going to add, and you'll see that that is down here. So now what I can do, instead of this option right here, I'm going to do a -1, and then I'll go down here and I'll say a +1 there, and that'll give me my new burn formula in this. Make sure only included. So now I've got my burn formula that I just created, and then I can just go through these plate formulas and just add this one instead of the other one. So really cool. Use those formulas to really do some stuff for you. I mean, think through. I mean, you can build coats into labor codes where you have a look at the flange width and everything, and you can build that into labor codes. It's just very, very versatile. So think a little bit out of the box, a little bit more than just using the codes that are here. Build your own, and these formulas can really, really help you do some things that really makes this thing hum. So hope this helps you, and let me know if you got any questions.